Algebra 2, 2.6a, conjunctions and intersections. Now I know we talked about this in Algebra 1. In math and languages, a compound statement may be made of several shorter statements that are connected by the words and or. My dog is little and fluffy may be true if each side of the word and is true. Well, Lola is little and she's fluffy, so both sides are true. A compound inequality may be true for x if each side of the compound inequality is true. X is less than 5 and x is greater than 0, well, then x can equal any number less than 5 all the way to 0, but doesn't include 5 or 0. So it could be 4.999. It can also be 0.00001, couldn't it? When two or more statements are connected together with the word and, they make a conjunction. So here we have one. We have a conjunction. -2 is less than x, and x is less than 1. So we can graph this. So -2 is not included, so we're going to use an open circle. And this is less than x, so x must be everything greater than -2. And x is less than 1, so 1 is not included, but it's everything that would be less than that. In set builder notation, we would write x such that x is greater than -2 and x such that x is less than 1. We can also graph it in interval notation with a parentheses to show it's not included, and it would be -2 comma infinity, because it's going on for infinity this way for the first graph, right? And we never put a box bracket next to an infinity symbol. It's always got a parentheses. And on this side, the 1's not included, so it's got a parentheses, and it goes on into -infinity. Now, looking at these two graphs, we can combine the graphs into one graph. We can graph the solutions onto one number line and say 2 is not included and 1's not included, but the numbers in between are. This is an intersection of the two graphs above, and in set builder notation, we can write it as x such that x is greater than -2 and x is less than 1. We can abbreviate this. And we start, after we say the set of all x such that, we start reading in the middle. Here. We start here. X is greater than -2 and less than 1. If we wanted to do this in interval notation on one graph, we would just combine the parentheses onto one graph like that. So instead of having it on two graphs, we put it onto one with the parentheses right here showing that -2 and 1 are not included, but everything in between is. And a conjunction corresponds to an intersection of sets. The big solution set for a conjunction is the intersection of the smaller solution sets. So these smaller solution sets are put together to make this big solution set for the conjunction. See that? We put these two together with the word and in between these two, and we can abbreviate it by writing it this way. See? So in set builder notation, we've got set braces on each side, right? And we put the x with the bar for such that, and then we write our inequality. And any object that's in the set is called a member or an element of the set. And you might see these symbols. This means it's an element of the set, and if it's got a line slash through it, it's not an element of the set. The set of common elements of two or more sets is called the intersection of the sets. We use the symbol, this upside down looking U, to represent the intersection. So here we have an intersection of two sets. We have set A and set B, and the numbers 1, 2, 3, 4, 5 are in set A, and the numbers 1, 3, 9, and 12 are in set B. They intersect where they both have the same elements, 1 and 3. So A intersects B at 1 and 3. See? If the sets have no common elements, well, the set is an empty set, and they use this 0 with a slash through it, or it's called a null set. Sorry about my focus there. So we can solve this negative 3 is less than 2x plus 5 is less than 7. We can say 2x plus 5 is greater than negative 3 or less than 7. We begin by rewriting the conjunction with the word and. So we've got it like this with the word and in the middle. See that? We just repeat this for the first one and again for the second one. We could solve these separately and abbreviate the answer. So we see it's got a plus 5. We can take away 5 from each side with the addition property of inequality. And that gives us negative 8 is less than 2x. We can use the multiplication property of inequality and divide both sides by this coefficient 2. We don't need to multiply by the reciprocal because there aren't any fractions and it's quicker to divide. So we get 1x on this side and we get a negative 4 on this side. So we know negative 4 is less than x. On this side, we can use the addition property of inequality and subtract the 5. We want to isolate that x, don't we? That makes a 0 pair, and now we have 2x is less than 2. We divide both sides by this coefficient 2, and we get x is less than 1. We can write this, negative 4 is less than x, and x is less than 1 in set builder notation, abbreviated as the set of all x such that, start in the middle, x is greater than negative 4 and less than 1. If we graphed it, it's an intersection of the two solutions. When it's not abbreviated, we can write it like this, and it just means that negative 4 is not included and 1 is not included, but all the numbers in between are part of the solution set. We can write it in interval notation with the parentheses. It's negative 4 is not included, 1's not included, and our answer is parentheses on each side with negative 4, comma, and 1. All right? Now our next video is 2.6b. We're going to talk about disjunctions and unions. You can go to the description of this video to see the growing Algebra II playlist. I'm going to add this one to it next if you want to catch up or review. And there's going to be a link to the information here from Algebra 1 when we talked about it. If you're really confused, maybe going back to when we talked about it in Algebra 1 will help you. Now, I found one of the things that really helps me with intersections is there's a word and in between them, right? And when I look at the symbol for intersection, it kind of reminds me of an A. All I have to do is cross it, see? And it makes an A. All right? Okay, I hope that was helpful. Keep plugging away. Keep trying. Climb that mountain with me, okay? We're going to make it. We're going to be okay. I'll see you next video. Bye.